Hey friends, Jeff Fritz here, and I want to talk to you again about the Intel Advisor software. This is a pretty cool piece of software that is allowing you to analyze your applications that were written in C++ and figure out where you can optimize things, how you can make your software, how to make your applications run faster with just a little bit of changes. It analyzes and makes recommendations to improve your performance. Now, one of the key features that it focuses in on is vectorization. Now, of course, many CPUs have vector or SIMD instruction sets, particularly those Intel processors. If you're like me with an i7 running inside your machine, you want to take advantage of all the cores that you have available to you. If you compile your code with the appropriate instruction set, you'll be able to take full advantage of all the processing power in the CPU. Let's take a look at a simple example of how we can take some matrix multiplication and update it with some slightly different compilation flags, maybe shift the structure of our code a little bit, and how the Intel Advisor can tell us to make our code better. All right, we're back and looking at this same very simple, naive construction of matrix multiplication. It's just going to run a couple for loops to calculate and do some multiplication across three matrices, C, A, and B. I'm going to compile this now and add it into the Intel Advisor and see what it reports for the performance and what we can do to optimize this code. Let's go take a look. So here's the roofline chart showing the performance of our application. And you can see the main loop is right here, and it took 73 seconds to run through that loop. And it only ran with one core, and it's really, really slow. There's this dependency report down here that says that there's some confirmation of dependency that we need to do. We should run dependency analysis to identify the real data dependencies so we can get into this a little bit further. We can run the dependencies analysis by going into the survey, selecting the loop that we would like to analyze, and clicking the Collect button over here under Check Dependencies. I'm going to fast forward the video here because the check dependencies takes a little bit of time to run, and we'll come back and see what the results are. All right, so here we have in our recommendations underneath the refinement reports, we have a series of compiler directives that it's suggesting that we add to our code so that we can improve the vectorization of this loop inside of our application. I'm going to apply this directive, recompile the application, and I'll rerun the roofline analysis and we'll see what's improved. All right, that looks better. We're approaching that first roofline here, but we're still not very efficient. We can tune even further. If we look at the survey here for that first loop, you see that we're only at 59% efficiency. We could restructure our code. We could do some other things to tune and improve this, but we're also using the AVX instruction set. If we take a look at the recommendations, it's recommending that we take a look at using one of the other compiler options to use the AVX2 or AVX512 compiler options. So you can see it's easy to find recommendations that you can add to your code, like these compiler directives and other analyses, getting reports and drilling in to find out where those hotspots are so that you can tune and improve your application. This is a simple example, but when you have a much larger application, this is going to become invaluable to you to help find, isolate, and make your applications better. Thanks so much for watching.